And welcome also from my side, and thanks a lot, Stefan, Johannes, and the BIMobject team for inviting Autodesk to present here. As said, my name is Uwe Wasserman. I'm leading the strategy around business development in AEC and Autodesk. And for those of you who might not know Autodesk, it's a global software company with around 2.5 billion of revenues. We have 3 business lines. One is manufacturing, and we know that we need to apply a lot of techniques from manufacturing into AEC in the future. Another business line is media, entertainment, and gaming, and you know, a lot of visualization stuff is also needed in our industry, and the biggest business line that we have is AEC, architecture, engineering, and construction. So today I want to talk about connected BIM and the disruption and transformation that this will drive in the AEC industry. But before I go into any detail, I want to give you a more global view. Disruption was always caused by technology changes. So technology changes always have changed the way we work. The first industrial revolution, as we all know, driven by watercraft and steam power, has extremely pushed productivity. In the second industrial revolution, it was the electricity that enabled standard production, mass production. In the third industrial revolution, it was the information technology, the electronics, the computer technology that have driven the automation processes. Now, we are in the fourth industrial revolution, which started mid of the last century, and it builds somehow on the third. The main features of this industrial revolution is the fusion of technologies. So the digital, the physical, and even the biological sphere is merging. And there are 3 reasons why this is a really new revolution and not just an extension of the third revolution. And there are 3 reasons for that. It's the speed, it's the range, and it's the systemic effects that it covers. So the speed that we see changing and dynamic of speed that we see in this revolution has never been reached before. It's developing exponentially compared to the other revolutions. Think about the spread of mobile devices in emerging countries, for example. The opportunities of billions of people connected through mobile devices with unprecedented capability and capacity is unlimited. And so is the access to knowledge for everyone. And these opportunities are even exponentiated by emerging technological breakthroughs that we see, like artificial intelligence, Internet of Things, robotics, bio, nanotechnology, all these new materials coming out of material science, or energy storage, or quantum computing. And artificial intelligence is already all around us. Think about self-driving vehicles. Think about drones or swarms of drones that control each other, or virtual assistants that enable to take decisions or prepare decision alternatives based on very complex relationships. The digital transformation is complex, from TV to gaming, music, or shopping. Each of these images that you can see on the screen is somehow a little disruption that we experience in everyday life. But the explosion of the digital context is changing everything what we understand so far about design and construction. Think about complex thermostat systems that control the physical behavior of buildings. Think about the microfactories that allow for off-site production, or prefabricated elements or panels that allow us to build more efficiently, all equipped with sensors in the future, because sensors get extremely cheap. And this allows us to track, geolocate using GPS, all these elements, link them back to the BIM model, and access them through the BIM model and the cloud from everywhere at any time. And by 2020, we will have 50 billion of sensors connected to the internet, creating immense volume of information that we need to work with. So connected BIM for us in Autodesk is BIM plus the power of the cloud. What this means is we are able to break down barriers. Barriers between physical and digital. Barriers of siloed work that we have in all these phases. You know, we heard about different stakeholders in different part of the project working together. And also, what it allows us that we can apply methodologies like manufacturing into the construction world. I want to talk about 4 main areas in a full building life cycle and start with the design. So by its heart, the collaboration in our industry is asymmetric. This is because we have a lot of different stakeholders, and every stakeholder is focusing on his discipline in different locations, in different times of such a project. So how to collaborate? Now, in the era of connection, using connected BIM technologies, we are able to support a common platform for all these people working together. This is a platform where you can upload information and access the latest version of everything, documents or models. We call it a single source of truth, or what we heard, common data environment, realized through BIM 360 from Autodesk. But communication is more. Communication has also to do with visualization. Immersive visualization technology, VR, virtual reality, or AR, is adopted quite increasingly with increasing speed in the AEC industry. Whether it's just to explore different design alternatives from an architect or the stakeholders around that, or to articulate design intent to an owner, or simply to explain complicated constructability issues to a worker in the field. This is an example from Tokyo, from an architect, explaining to an owner who sits 500 kilometers away in real time through the cloud some impacts of the design. This happens today, and we just heard it from the speaker after the lunch. But the cloud is also enabling us to use tools through the cloud that we have never been able to use before because they have been very expensive, or they have been very complicated, or they have been not able to run on a desktop computer. But through the cloud, this is an example of computational fluid dynamics, very complex, and it is why doesn't it? Oh yeah, okay, sorry. This is an example of CFD that is optimizing the airflow in an operation room. I think none of my slides work because I have AVIs on them, on every one. That's unfortunate for you guys. Okay, this is working. Okay, this is another example for a cloud-based analysis tool. This is crowd movement analysis, where the architect can look into different conditions and stress conditions like fire alert of crowds and how they behave. And then it's highlighted through the heat map where the problem areas are. And the next step, what we currently do, is to drive geometry, drive layout based on desired people flow. An important thing is that we need to understand cloud enables all the stakeholders in our industry to have access to unlimited computing power. We call it infinite computing. Why is this important? Because it enables everyone to perform very complex problems in kind of a routine way, in a real time. So in this example, an engineer would kind of change the structure of this building and directly gets the result in real time. In this case, it's tension, it's shear force, and bending moment. And he can kind of react very quickly on any kind of request coming from stakeholders or coming from the owner. Or he can, and what is more important, do iterative steps on optimizing this design. When it gets more complex design tasks, you can even use the computer to make design proposals to you. We call it generative design or computational design. It's nothing else than an emulation, a simulation of an emulation process, where you start with a certain design, give rules of this project, and the computer runs permutations based on certain convergence criteria until the best solution is found. I just want to talk a little bit more about this data-driven design development methodologies. And there are two things, and we heard about this earlier today. It's about the computational and generative design stuff, and it's about artificial intelligence and machine learning. Generative design. What we do in generative design is not just working on a design and simulate an analysis design, even not before or during the design. What we do is we use the simulation to discover the design. As I mentioned, we just use this rules of this project. We define forces at play, we define constraints, and the computer comes up with a proposal you might never have come up with yourself, but it's the optimized one. Interesting is that with the cloud, we see transforming the tools that we use to design and make things, but vice versa, the very things that we make are also transformed through the tools that we use, that you can see here. Let's look to a more, let's say, practical example. It's the Museum of the Future in Dubai. And the architect has designed this very organic, complex shape with freeform shape. And to make it buildable, to make it constructible, we need to structure it somehow. We need to polygonize it somehow. We need to define the nodes. We need to define how we apply structural analysis, what material we use, and so forth. So what happened with generative design, Bureau Hubbell, the customer of ours, used Dynamo, which is directly linked to Revit, to optimize this. And what they achieved was they were able to reduce the number of nodes by 40%, which makes it much easier to construct. They were able to reduce the weight of material by 30% and get very, very close to the original design deviation reduction by 80%. And the result is really amazing. Now let's look to machine learning. Machine learning, and I need to speed up a little bit. So an easy example is self-driving vehicles. Self-driving vehicles do not run with the old logic of if-then philosophy, right? What you do usually in analysis products. You have information and you analyze it. It's not a feature and function thing, it's an insight. It's anticipating what will happen. So it's not looking into the raw mirror, because this is if-then. We need to look forward into the future and anticipate what will happen. Like this example where a car is sensing kind of the environment, learning, and everything the car learns, the system learns, is available for all other systems because they are connected. So the learning curve is extremely steep. So what this means is machine learning is kind of an artificial intelligence that enables the computer to learn without being explicitly programmed for it. The system just learns by being exposed to data. What this means for you is, imagine if you would feed such a system with all your experience of past projects, and the system would apply this information to future projects and avoid any kind of mistakes you might have made in the past. And of course, the computer calculates a lot of these alternatives and comes up with, in this case, it was around 10,000 different alternatives. All these proposals meet the convergence criteria that have been defined before. But then you need to analyze with a ranking weighted analysis and come up with the more or less final proposal. Okay, it's not working. No, it's working. So with the final proposal of this layout. So this machine learning examples. Now let's move to the next area, which is fabrication. And I think it's important to understand that we need to connect design to fabrication, but also optimize fabrication methodologies like we learned with technologies coming from other industries, especially from manufacturing. And there are different examples, and I think you have seen a lot of them already. On the left-hand side, there is the 30-story hotel. There's a AVI running in the background. I don't know why it's not working, but this is something which was possible through a very high level of prefabrication of elements combined with logistical optimization and lean management. On the right-hand side, you see modular construction, which is nothing else than prefabrication combined with pre-assembly, and then and you see the middle example is the B2 Brooklyn, the stack, and on the right-hand side the B2 Brooklyn yard, just two examples of such modular construction. But this is not only possible for modular construction, you can also build buildings or big building parts off-site and then ship them to the destination. I mean, this is an extreme example, but it shows how creative construction industry meanwhile gets. This is an example from Norway. But it's not only possible to drive standardization with digital fabrication. You can also make interesting buildings buildable. In this case, it's the Museum of Modern Art in San Francisco, and the facade elements have been 3D printed, fiberglass reinforced concrete, and then cut with milling machines. Also here the video is not working, but at the end the result was impressive. Now it's coming. So, okay, the 3D printing was part of the design process in this case. And we also saw some of these examples of other 3D printed buildings. This is a 3D printed office building in Dubai, and Sheikh Mohammed of Dubai stated that he will print 25% of all buildings in Dubai by 2030. And he has a lot of sustainability targets associated with that. This is an example from infrastructure. I think we heard about this today. It's a research project we did with MX3D and Heymans contractors in the Netherlands. This is an interesting example because it combines computational design with 3D printing. So the load capacity of this bridge that spans a canal in Amsterdam, the load capacity was maximized and the weight was minimized using computational analysis. And this is the reason why you see this crazy filigrane forms of this bridge. And then out of Revit, directly the robots have been driven and printed this bridge. Very interesting example. Let's move to the execution on-site. And of course, I can only touch the surface here. We all know it's a very, very highly analog process that we see in the construction execution. And there are different trends that we see. One is, of course, the common data environment topic, that everybody on-site has access to the latest information, tracks this, and optimizes logistic-wise. But one important trend that I want to touch on is the integration of different kind of hardware into a BIM-driven workflow. This example is, of course, the... No? I don't know Well, this is not working. So reality capturing is one of these things where you define areas you want to explore on the tablet, and the drone starts itself and makes all this capture automatically. And you can use this for different things. You can use it for capturing model information. You can use it for quality assurance, for safety. And often it's used also for progress management on the building site. Another example where the BIM model is kind of driving processes in the field is this example where the hangar points have been exported from Revit and directly fed through the cloud into this mobile robotic drilling machine. And the contractor stated that the time saving has been it has been 8 times faster than traditional methods and much safer and much more precise. Another thing is reducing risk and increasing safety on the building site. It's not working. Maybe you can click on this and show the video. I'm not sure. So what this video shows here is that you can define areas of danger in the BIM model, and through the cloud, it is connected with a worker who has a sensor. And if the worker walks into this area, the jacket vibrates, and at the same time, the supervisor gets an alert on his tablet, so he can react. This is what should be shown here. Another example is also efficiency and safety, augmented reality, and there are many examples of augmented reality that are currently worked on. This is one. This is the so-called smart helmet. And what you can do is, through the visor of the helmet, you can not only see the reality, but you can overlay the BIM model. And you can look into the ceiling, you can look into the wall, what is behind, what is inside the column. But you can also navigate to an asset in the operation phase, touch this asset, and context-sensitive get installation instructions of this asset. So it's all kind of driving efficiency on-site and in operation. Last but not least, what does connected BIM mean for the operation phase? And there's, of course, also a lot of examples, starting from asset management through maintenance or predictive maintenance or all aspects of renovation until the degradation of structures. But in interest of time, I just want to touch on one of these things, and this is monitoring of building performance. And although this video is not working, so what you would see here would be the following. So we have developed a prototype, and you can, by the way, Google it. It's called Dasher 360. You can check it out yourself. And what it does is you can access a building. It's a kind of IoT project, right? Where the building is equipped with a lot of sensors. And then you can take your tablet, your mobile, whatever, and check real-time cooling, heating, any kind of occupancy, movements of people, or you can check logistical aspects or lighting. What this means is really we are moving into a optimization of sustainability optimization of buildings in the operation phase. And we are all looking, I mean, to you guys, building product manufacturers, double down on this effort because it really helps to provide more services to the owners, and it helps you also to be kind of designed in early in the phase, in the project development phase. Yeah, with that, I just want to summarize. So, connected BIM goes beyond a pure as-built or design or as-maintained model. It really includes capabilities and processes that leverage the power of the cloud to support deeper insight, to optimize the design using different kind of analysis, simulation tools, generative design, machine learning. It also supports enhanced collaboration between all these stakeholders in different disciplines using a common data environment. It also improves project delivery through what we just saw, the digitalization from design through fabrication out into construction. And of course, it helps to better understand and manage real estate and the assets. Interesting is that, and I think this is an important thing, all these capabilities are accessible and available for any company in the world, independently of the type, of the size, or the location. The barriers for everyone to participate in this digitalization world is relatively low. Thank you very much.